Ladies and gentlemen, with our next speaker, we really won the lottery, and it wasn't even intentionally. But if you believe it or not, she did not only also study computer science, so again, one of the 19%, but she will talk about the uptake of open science resources in industry. Is it a reality or only wishful thinking? So what we already had also in our first talk as a challenge. So Angela will solve all of our problems, but no pressure. Angela Fessl has a master's degree from the Technical University Graz in computer science, or more in detail in telematics, and she also received her PhD there. And she's a deputy research area manager of the area data-driven business at the KNOW Center in Graz, we also heard about already. And her research focus is on learning and educational technologies, digital transformation, and related digital competencies, knowledge management, and knowledge transfer. Please welcome on stage with me, Angela Fessl.
Yeah, thank you very much for this very, very nice introduction. As Andrea already said, I'm from the KNOW Center. The KNOW Center is a research center in Graz, Styria, Austria. And it's called Research Center for Data-Driven Business, Big Data Analytics, as well as Artificial Intelligence. So the KNOW Center covers a lot of these topics about data science, but we also do more. As Andrea said, I'm from the area data-driven business, and we are dealing especially with data-driven business models and especially with educational technologies, but we also deal, and this is what I present in this talk, with research about open science to a certain degree. So before I start with my presentation, I have a question for all of you, and I would like to raise your hands if you agree or not. Who of you knows what open science is? Okay. Who of you has already used open science resources? It's getting less. And who of you is working in a company that offers open science resources to the public? Okay, one. So open science is a big topic, and you see, I think we have to improve not only us, but also our companies in this direction. And with this, I would like to start my presentation about the uptake of open science resources, reality or wishful thinking. And as you've seen now, we have only raised one, or only seen one hand raised of a company that offers open science resources. So in general, what is open science? I have here two definitions. Open science is the idea that scientific knowledge of all kinds should be openly shared as early as is practical in the discovery process. And another definition, open science is transparent and accessible knowledge that is shared and developed through collaborative digital networks. What is now open science? Okay, there's a problem with my presentation. Anyway, open science, if we summarize it, there are 6 meta concepts that describe open science very generally. Open access, meaning freely available, accessible publication of current research. Open data, we are talking here about data sets that are freely available to everyone for reusing and do whatever you would like to do with them. Open source code, meaning there is freely available source code on different platforms with different program languages which you can reuse for your own services and products. But there is more, like open methodology. This is something which is very practical and often used in the area of medical research, where you pre-register your evaluations so that you are able to say, if it's necessary, I was the first who would like to do, or who had the idea of doing such an evaluation. Open peer review, you all know conferences or journals where the papers are peer reviewed. Why not doing it openly and make these reviews accessible? And open educational resources, this is especially relevant for teachers or lecturers at schools and universities, where learning or teaching material is freely available. and there is much more. I will focus mostly on the three topics here: open access, open data, and open source code, and give you an overview of how open science resources in this regard are currently uptaking. Very briefly, this is research in two projects. The one project is the project called On Merit that deals with the Matthew effect. The Matthew effect says the richer get rich, and we had three research streams there. One for researchers, one with policymakers, and the third part was about the uptake of open science resources in industry. This is where I will present you some good and nice and maybe interesting, or hopefully interesting results. And we have another project called Triple. This is also an EU project still going on for 1 year. There we are investigating how to design technology to support the uptake of open science. There we'll give an outlook of our current research and what we are trying to do at the moment. So let me first focus on Merit. What we did there in order to find out if open science resources are already uptaking in our industries and in SMEs in Austria, we did an interview study. We had 13 participants, and relevant here is 13 all of them had a master's degree, and 4 of them had a PhD degree. We had interview partners from 11 different companies in the domains of health, agriculture, and climate. We developed an interview guideline for them and had about 30 minutes to 1 hour talk with them. Based on these results, we created a questionnaire that we send around across Europe using the platform Prolific. And here we received 103 completed forms. Again, here more than 60% had a university educational background. So I will keep this rather short, but now let me show you what kind or what type of open science resources are already taken up in form of some examples. If you think about open data, people use weather data, location data, also OpenStreetMap data, and corona data. So for example, one interview partner of a company that produces some product regarding the increasement of your immune system, they looked at corona data and made some sales or marketing strategies according to this data. Where corona numbers were high, they focused more in the pharmacies on advertisement of their products, for example. Or OpenStreetMap, OpenStreet data. We had one participant saying, if they go, they're working in Asian countries, if they go there and there was a thunderstorm or something similar, they first look at OpenStreetMap in order to see if the damages are too big or very enormous before they go there, just as 2 examples. Regarding open access, so freely available publications, our interview partners and also the questionnaire answers showed us that the people like to use preprints on Zenodo, for example, Archive, for example, as well as Google Scholar. They mentioned SciFinder and PubMed. However, for example, in PubMed, the publications are not freely available. You can only see the title and maybe the abstract. And what our partners say, especially from the small SMEs, they typically have close contacts to university people and ask them to get, for example, publications they're interested in, because for a small company it's really, really expensive to enroll and subscribe these journals. Finally, open source code. This is also used. I will come to this later. They mentioned machine learning source code. They mentioned special libraries. But typically, you really have to think of, if you're a small company, if you're, for example, a startup, should I use open source code or should I do it, program my services and software for myself? This is a decision you have to take at the beginning, and I will explain in a minute why. So there are a set of drivers that really foster the uptake of open science. So for example, as I said, in the interview results and the questionnaire results, most of the people who heard about open science and this movement have a university education, at least a bachelor's degree. Those people who have not studied at a university, most of them have not heard about the open science movement in general. So companies can benefit by hiring people with with a bachelor degree or higher to bring open science knowledge into their companies. What we also found is that incentives or also support might help to make open science more available. Companies should allow their employees to spend a significant amount of time in open science activities, like attending relevant conferences, like giving them the possibility to access relevant platforms, and so on and so forth. Training activities could be a driver, so provide instructions on how to use open science resources, show existing possibilities. So, for example, the government of Austria has an open data platform where you can find information freely available, give links, give tips where to start, but also, and this is now the cross-link to the other project, how could we design or use technology to support the uptake of open science resources? From trans and interdisciplinary cooperations you can learn. So look what other people are doing, look what other project partners are doing in this regard. You can learn from others. And finally, exploit the wisdom of the crowd. This is especially very relevant regarding open source code. If you imagine, I don't know if you know, but it's for example, the learning management system Moodle. This is an open source code platform. Big universities, like for example, the Graz University of Technologies, are using it as their learning management system, and this source code is available for free under specific license, yes, but you can use it, and typically you also develop something there and give it back, so that this source code is growing, improving, and maintained over time. In contrast to these drivers, we also found some barriers regarding the uptake of open science resources, for example, regarding open data. Health-related data is scarce because of GDPR, because of privacy. There are license restrictions for commercial use of some data sets. And there is also a lack of clear steps, where to begin, how to proceed, where to find relevant data, and so on and so forth. So for some of the people in the questionnaires, in the interviews, it's not so clear how to start with open science or open data. Open access, this is a very hot topic. On the one hand, open access publications are limited. If you publish, for example, if you write a paper for a high-level journal, you have to pay these open access fees that are really, really high. If you go for a high journal, you pay around 2,000 euros. So, for example, the University of Graz of Technology pays for some journals. In other countries, this is not the case because it's really, really high, the fees there. And on the other hand, subscribing to high-level journals is also very, very expensive. So we have this trade-off there, publishing open access, but also accessing or using open access, it's really costs a lot of money. And finally, open source code. Yes, it sounds great that there's a lot of open source code out there that you can reuse, that you can improve, that you can extend or expand or whatever. On the other hand, if you're a small company, you really have to think about, should I use open source code or not? Because if, for example, you develop a product or a service where decisions are made by your customers, and this decision is based on this source code, and the decision they made is wrong because the results of some algorithms is not what it should be, then you might have a problem. So really, because you can use the code, but you don't know what's in the code if you don't look at everything. And then it's a matter of reliability and a matter of validation and a matter of compliance, especially if there is a lot of money in the game. So this is what I wanted to say about our on-merit project and what we found out. And now the question is how to design technology that might support the uptake of open science. And there, especially, how can we design technology? What we did, or what our goal is there in this triple project, how can technology design support knowledge construction in the sense of learning? How is such technology design applicable in open science platforms? And summing this up, our main goal is how can open science platforms support the uptake of open science resources through the help of technology, with the help of interventions, or whatever you think about. So what did we do? We first did, so we published a paper on this on the CHI conference, which is a high-level A-star conference on computer-human interaction. On the slides there is the reference if you're interested in. So we did an analysis of literature in this regard and synthesized the results. In parallel, we looked at open science platforms and defined core components, so components that are available on several of these platforms, like a discussion forum. And then we derived design implications, so what is on there, what could we do? So for example, we could present visualizations for collaboration. Typically, such platforms have some recommender system behind, recommending you some other resources or some other publications in a similar way that are dealing with a similar topic. There are digital tutoring approaches like prompts that give you some questions to guide you. There is guidance through chatbots. Some of these platforms have already chatbots implemented to a specific topic. And what we are interested in, what we think might be useful, are concept maps. Concept maps are like a map that present concepts and the relation between these concepts. And what we are currently working on is a very cool and interesting study. We are interested in if a concept map could help you to understand a scientific publication. So our setup, so the experiment is starting next week with our students. Our setup is, we have a paper, a very simple one, or a psychology paper of 4 pages. And if you have read one of the paragraphs, you click the checkbox, the checkbox, and based on what was read in this paragraph above, is displayed in our concept map. And when you move over the concept map, then you get a description or definition of the concepts so that you have a possibility to understand this paper. This is what will start next week, and we are very interested if this really helps. So summing up, what I was talking about or presenting to you is that the uptake of open science resources in SMEs in industry is not that far. There exist a lot of drivers, there exist some barriers why this is the case. I think this should be extended a bit. We are currently investigating how to design technology that supports the uptake of open science on, for example, open science platforms. And we are currently working on this study as a kind of proof of concept. And with this, I think it's important that open science gets a little bit beyond the research, gets a little bit out of the context of universities to everybody. And we are hoping that we could at least go one step beyond this with our focus and with our research. And with this, thank you very much for your attention.
Thanks a lot. I will just go to the next slide because there we have still your references so we can put them on while I ask my question at least. So thanks a lot. We already learned data science is interdisciplinary, and everybody has, I have the feeling everybody has an own definition. So kind of, what is data science? What do you think, or how you would you describe data science in your context?
Data science, as we heard, and I fully agree with Anja, is interdisciplinary. So I'm not a data scientist, I'm from the side of computer science. So I think data science is majorly the statistical stuff with this outlier detection and this time series whatever and machine learning and I don't know what else. However, I also agree, and this is what I also agree with Anja, is you always need to take the human into account. You can define a lot of algorithms, machine learning techniques or whatever, but in the end the humans have to deal with it. So from my perspective, this is one of the crucial things that is sometimes missing.
Thanks again. And with that said, I'd like first, thanks again.